The measurement of the elementary charge was done by Robert Millikan's oil drop experiment at the University of Chicago in 1909 to 1913. His apparatus used to measure the amount of charge an oil droplet carries is like this. Tiny oil droplets are sprayed into this chamber. Many of them become charged either positively or negatively in this process. Some of the droplets would fall through this hole and enter this region between two parallel metal plates. The metal plates are connected to a power supply, so the experimenter can control the voltage and adjust the electric field between the two plates. Now the experimenter would pick one oil droplet to follow, manipulate, and observe through a telescope. Inside here, an oil droplet can experience three forces: the gravitational force mg, the electric force QE, and the air resistance. And the air resistance is dependent on the size, the radius of the droplet, and the speed of the droplet. Depending on the electric field in this region, the sign and the amount of the charge a droplet carries, the droplet can be falling, moving upward, or even suspended in midair. For example, if the electric force QE on a droplet goes upward and it is strong enough, the droplet can be moving upward. In this case, the air resistance will be going down against the direction of motion. Because the droplet is very small, air resistance is important. The droplet would reach terminal velocity very quickly. This means the droplet has a constant velocity and the net force on the droplet is zero. So the upward force QE would equal to the downward force mg plus the downward air resistance force. Because there are multiple unknowns, such as the charge on the droplet and the radius of the droplet, we need more than one equation to figure out the charge on the droplet. Therefore, the experimenter has to follow the same droplet for a while to manipulate its motion and record enough sets of data on the same droplet in order to get a good measurement of the charge Q on that particular droplet. Millikan would do this for many droplets. He discovered that the amount of charge on a droplet is quantized. Q equals to a whole number n times the elementary charge E. He found the common factor, the elementary charge, to be very close to what we use today, the E equals to 1.6 times 10 to the negative 19th coulomb. Because back in 1897, J.J. Thomson has already measured the E over m ratio for electrons. Now with the elementary charge measured by Millikan, we have the mass of the electron, which is about 1,837th of the mass of a hydrogen atom, just as expected by J.J. Thomson.